Hello everyone, I hope you are doing well. In this tutorial, we are going to see how we can analyze and interpret descriptive statistics using JASP, which is an open and free software. So first we need to understand what descriptive statistics. So descriptive statistics are divided into two major categories: measures of central tendencies and measures of dispersion. For the measures of central tendencies, we have the mean, referred to as the M, the median, and the mode. For the mean, it is simply the average of all the values given in a set of data, and the mean is the sum of all values divided by the total number of the values. Like here, we sum up all of these values and we divide them by the number 4, because there are like 4 items, like 1, 2, 3, 4. So that's going to give us the mean. If we keep them without division, that's going to give us the sum score. So this is used mostly in Likert scale questionnaires. So for the median, it is simply the middle value in a set of data. Like here we have 3 data points, so the middle value is 6, so this is the median. And here they are sorted from the lowest to the highest, of course. That's what you need to do. Sort them first, then see the middle value. Sometimes it could be 2 medians at the same time. Then we have the mode. So the mode is the number that appears most frequently in a set of data. We can find the mode by counting the number of times each value occurs in a data. Like here, the mode is 5 because the 5 occurs 2 times in this data set. That's why it is called the mode. So like in Likert scale, so if people keep choosing 3, neutral, 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 3, so 3 is the mode. So this is in brief how we can, this is how we can understand measures of central tendencies within descriptive statistics. In research, mostly we use the mean from measures of central tendencies for normally distributed data, and the median when we have non-parametric, non-normally distributed data, because the median is robust against outliers, etc., as you can see. But here, if there are like some outliers or extreme values, that would inflate the mean. That's why we resort to the median for non-parametric statistics, and we resort to the mean for parametric statistics. So for the measures of dispersion, we have the variance, the range, and the deviation, or what we call the standard deviation. So the standard deviation is the one that is the most important one. So the standard deviation is the average amount of the dispersion in the data set. It tells you on average how far each value lies from the mean. So it is referred to in medical studies as plus minus the mean. So this is like the standard deviation. So the formula is easy. It is square root of the variance, and it is calculated using some tools like SPSS, JASP, Jamovi, etc. For the range, it is simply the difference between the highest number and the lowest number. And small range means low variability in a distribution, and means that the data set is homogeneous, not heterogeneous. The variance is how spread the data is, and the more spread the data, the larger the variance is in the relation to the mean. So like here we have, we just, for each number, we subtract the mean and square the results, work out the average of those squared differences. So we're not going to calculate these manually. So once we are on JASP, we need to compute the descriptive statistics of these constructs here. So simply we go to descriptives, and then we are going to put the variables that we want to compute, like these. Click shift so that we can select everything here. And here we will see the variables, and we see the mean, the standard deviation. See the mean as a measure of central tendency, and standard deviation is as a measure of a dispersion. We have minimum, maximum. Of course, you can customize this. You can remove the missing values. You can remove the valid values. If you want to include the quartiles, you can include them as well, like the 25th, the 15th, the 75, or the with percentiles. Then if we want to add distribution like skewness and kurtosis to check normality, you can add them as well. If we want to add Shapiro-Wilk, you can add it. You can add it for the central tendency. You can customize it into mode, median, etc. So this is distribution. That's another thing. We are not concerned with it now, but you can find it in the descriptive statistics menu. For this dispersion, you could see here the standard deviation, the MAD, the interquartile range, the maximum, the minimum, the variance, MAD robust, coefficient of variation. So we just keep the standard deviation, and that's it. So minimum, maximum, we don't need them. We remove the quartiles. Here we have the standard error mean and the confidence interval for mean. We have confidence interval for standard deviation, confidence interval for variance, bootstrap confidence interval. You see, JASP gives you different options for inference as well. We can also visualize this data by going to the distribution plots, like display density, etc., or interval QQ plots, etc., to see whether the data follows like normal distribution. You could see here mostly it is concentrated towards 6 and 7, and if we just interpret this from 1 to 7, you could see this is like a 7-point Likert scale, and you could see the density of each response. So mostly here performance expectancy, most respondents tend to agree towards the positive side. The same for this construct, towards the positive side, so it is to the right, so it is mostly agreement. And here are also towards the positive side, but here they seem to be skewed a little bit. So if we go back to the interpretation of the mean, we will understand, like here we have the mean as 5.4, 5.48, 4.6, and 5.4. So it seems that this one has the lowest mean as visualized here. So how can we interpret the mean and standard deviation? This is the overall mean and this is the overall standard deviation. So we go back to this table that I put. I'm using 7-point Likert scale, and these are the ranges that you can see. So for the 7-point Likert scale ranges, for strongly disagree to strongly agree, you could see from 1 to 1.85 for the mean score. It means strongly disagree. From 1.86 to 2.71, this means disagree, etc. 2.72 to 3.57, this means somewhat disagree. If the mean score is ranging from 3.58 to 4.43, it means neutral. If it ranges from 4.44 to 5.29, it means somewhat agree. If it ranges from 5.30 to 6.15, it means agree. And if it ranges between 6.16 to 7, it means strongly agree. If we go back to the results and interpret this, let's say for the first scale, here we have the mean as 5.41, and if we go back to the reference table, 5.41, it falls here. So it means that most respondents agree. So this is how we can interpret if it is a 7-point Likert scale coded from 1 strongly disagree to 7 strongly agree. I have another table or tables that explain all of the 3-point Likert scales and their intervals according to this reference Pimentel 2019. For 4-point Likert scales, 5-point Likert scales, 6-point Likert scale, 7-point Likert scale. If you need this table, I can share it, or these tables, I can share them with you. Just comment so that I can know that you need that. And this is for the binary scale, the interval difference interpretation, etc. So the mean can be interpreted according to these thresholds, and these tables will really guide you because the mean is needed also when you are running inferential statistics, whether you are running ANOVA, independent samples t-test, paired samples t-test, one sample t-test, and COVA, analysis of covariance. You will need it in all, especially in the differences, to see the mean scores and the standard deviations of different groups. That's why this is really important, and you will need to interpret the mean score or the mean scores according to the scale that you are using, whether agreement scale or other scales, effectiveness scales, etc., depending on what you populate here in terms of the interpretation. So the interpretation, in fact, depends on the way you code the Likert scale and the thresholds that you get in the mean score. So this is in brief how we can run descriptive statistics, especially measures of central tendency like the mean, and measures of dispersion like standard deviation, using this free open source software which is JASP, and this can also be applied by Jamovie, which is another free open source software, or some AI tools like Julius AI or SPSS or even Excel. So these are all tools that can be used for data analysis. You can also use some coding languages like R and coding open source software like R, etc., to do the data analysis as well. So regardless of the software, be it Minitab, eViews, whatever, so you need these thresholds, especially when it comes to data analysis involving the mean of Likert scales. So thank you. I hope this tutorial has helped you understand how to run and interpret the results of descriptive statistics. See you soon, and bye for now.